Hello learners, welcome back to my channel. Today we are going to solve a small case of logistic regression. So here it's a case of micro mortgage analytics. Here we will try to solve a problem of unorganized sector. 90% of the people in India works under unorganized sector. Many of them have to buy a home, a dream home. But due to lack of documentation such as salary slip, bank account, PAN card or IT return, their loan gets rejected. Imagine one small Karyana owners who has a monthly income of 30 to 40,000 and have a saving of 5 to 6 lakh can afford a house, but due to missing of documents his loan is rejected. So for solving this kind of problem, one company or one small bank came into picture, that is Gjan Housing Finance Limited, which is a micro mortgage finance company. It tries to work under Roji Awas Yojana and tries to give the loan to such unorganized sector. But there is one problem. As the unorganized sector is there, the people or the chances of default is more. So they have to verify credibility of applicant thoroughly. So Gunjan Finance has to check the applicant's credibility, and for that per application cost comes to 8,000 rupees. What is the process of credit verification? So I am making it very simple. First, application or applicant has to give application to a bank. The bank will check the credibility by checking or by calling a reference and all other things, check all the documents. And more important, after that they try to send a field inspector to check whether all the details filled in a form are correct, whether the earning, whether the shop, whether the loan provided to the asset is there or not. On the basis of it, the approve or rejection decision is taken. So here the business problem was, can we build a model that tell us to reject the customer's application at very initial stage of verification to save the cost? In simple terms, can we just reject the application from this stage, like when we check the documents and all that? Is there any probability that we can reject the loan? So many times, no, this is more important. It saves the verification cost. So this is our main objective, and this is a problem of logistic regression because our dependent variable is a categorical variable, a factor, because y is equal to 1 is approval of a loan and y is equal to 0 is rejection of a loan. So we will apply a logistic regression to this problem. I will just give very basic theme of logistic regression. Always remember, it tries to identify the class probability. In this case, we will consider y is equal to 1 and we will find the probability, and on the basis of it we will decide whether to provide loan or not. So let's have a hands-on to blue sky statistics for one variable regression, and in this case I will take LTV as my independent variable. LTV means what? Total amount of loan required against the market value of property. I will give a basic example. If I want to buy a house of 10 lakhs and if I apply the loan for only 5 lakhs, and then it increase the chances of approval. Similarly, if I want to buy a house of 10 lakh and if I take a loan of 8 lakh or 9 lakh, it will try to reduce the probability. Let's see the model, and on the basis of it, we will try to interpret it. So I will just try to open my blue statistics. This is there. I will open the file. So basically, I have made this variable, and you can just open it, sheet 1. Sorry, sheet 2 was there. I'm just reopening it. So this is again LTV. Try to open sheet 2. These are the two variables of data. The decision is my obviously y variable, and LTV is my loan to ratio of loan to asset value. So this basically is given. So decision basically by default it is taken integer. I have to make a factor here. So I have just changed to factor. Now I am trying to run a logistic regression. So first go to model fitting, try to click on regression, try to go to logistic basic regression. Obviously your dependent variable is your decision whether to approve loan or not, and your independent variable is your LTV. Okay, and try to plot all the required plots. Just tap play button, you will find all this. This is what a regression model looks like. So here your alpha plus beta 1 into x variable, so this is your y variable, and same your alpha beta has been written here. uh, this is a null device. I always say how far your model is from best model. So null device is there. When we will run multiple regression, I will show you why it is used. On the basis of it, this is my basic output. I will select it. I will copy it to new Excel file. So I will open new Excel file very fast. Blank Excel. I will just give paste here. You can see this output. I will just zoom it more. So this is my intercept beta 0, this is my LTV, and this is value of slope. So I will just write here beta 0. You can also write alpha. This is my beta 1. I will just copy this both value and write here. Now here I will write Z value. So how to find Z value? Sorry, I will write here LTV. I am first giving a ratio of 50%. In other words, if my if my asset is of 10 lakh and I want only loan of 50% of 5 lakh, so I am giving a ratio of 50%. Here I will find a Z value. So how to find Z value? Just write equal to this plus this multiply this value. You can find it 1.68. Now I want exponential values, so I will just write here exp and I will give the value of 1.68 and I will just click enter. Now I want probability of y that is equal to 1, y that is equal to 1. I will also write, so here what I will do, equal to this variable divided by 1 plus this variable again and just enter it. So you will have a chance of 84% of approval of loan because your value of asset is more than your loan amount. Now I am changing it to 60%. You can see it will reduce the probability. If I just change to 80%, you can see the probability comes to 68%. If I take a value of 120%, like for example, my asset is of 10 lakh and I want a value of 12 lakh, you can see the rejection chances are increased like 0.39 or maybe 0.40%, less than 50%. So more times it would reject the loan. So this way we need to solve the problem. Thank you, students.